بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Today we will begin a new unit, which is the unit of complex numbers. The first part talks about oriented angles. Now, what are the other properties of oriented angles? UV is an oriented angle such that one of its measures is alpha radian and K belongs to Z. This is U, this is V, and a measure of this angle is alpha. The first property states that VU is minus UV plus 2K pi. Let's see it graphically. This is U and this is V, and this is the angle in between. Now, if I want to talk about the angle between V and U, I have to go clockwise from V to U. So that's it. This would be minus alpha. So the relation between VU and UV is that VU equals minus UV. Now, minus UV is pi plus UV. Let's also see it graphically. This is U, this is V, and this is alpha. Now, what do we mean by minus U? It's a vector which is opposite to U. So this would be minus U. And we are interested in the angle between minus U and V. Now, if I see it in this orientation, minus U, V, it would be pi plus this quantity, which is equal to alpha. So it will be pi plus U, V. Now, UV is the same as UW plus WV. This is what we call Chazel's rule. You know it from before in vectors. Let's also see it. This is U, this is V, this is alpha. We can see from here that a measure of UV is the same as a measure of UW plus measure of WV. And finally, LU, L prime V is the same as UV, where L and L prime are strictly positive real numbers. What do we mean by this one? Remember, if we extend or minimize vector U in the same sense as U, and minimize and or extend vector V also in the same sense of V, the measure of the angle doesn't change. So the measure of the angle doesn't depend on the lengths of its sides. So this will be the same as alpha. That's why if we multiply vector U by a certain constant, whether it's greater than 1 or between 0 and 1, and similarly for vector V, nothing changes. Now some consequences. The measure of the angle UU is 0 plus 2k pi, and the measure of the angle U minus U is pi plus 2k pi, and this is very logical. UV is an oriented angle such that its measure is 2 pi over 3 plus 2k pi, and the question is to give a measure of each of the angles given below. When it comes to give a measure, we don't have to write this 2k pi. Now UV is 2 pi over 3. What do we know about VU? We saw from the properties that VU equals minus UV, so we just multiply the angle by a negative sign. So it becomes minus 2 pi over 3. Now minus UV, also we saw in the properties that to eliminate this minus we add a pi. So minus UV is pi plus UV, which is pi plus 2 pi over 3, which is 5 pi over 3. And then 2U, 3V, we saw it also, if we multiply by a positive constant, nothing changes. So 2U, 3V is the same as UV, which is 2 pi over 3. Now, if we have 3V minus 2U, this is a little bit complicated. Remember here, we flipped the vectors, we multiplied by a minus. So 3V minus 2U, to eliminate this minus, we just add a pi. So this would be pi plus 3V 2U. But what we know is related to UV rather than VU, so we have to flip the two vectors And in case we flip the vectors, we multiply by a minus, so this would be pi minus 2u3v, which is pi minus 2 pi over 3, which is pi over 3. Now this is application 3. In an oriented plane, ABCD is a direct parallelogram such that ABAD is pi over 4 or 45 degree, and CD is perpendicular to DB as you see in this figure, and I is the midpoint of BD. Now give the measure of each of the angles given below. When it comes to the measure, we have to put 2k pi. So if we need to give a measure, we don't put the 2k pi. Whereas if we need to talk about the measure, we have to put the 2k pi. Okay, ADAB, try to do it alone. Well, this is ADAB. Geometrically, it's a 45-degree angle. If we rotate from vector AD to vector AB, we rotate clockwise. That's why it becomes negative pi over 4. CDCB. Try to do it alone. Geometrically, it's a 45-degree angle because opposite angles of a parallelogram are equal. And if we rotate from CD to CB, we rotate anti-clockwise, so this is positive. Now you see in parts A and B, this is very easy because we begin by the same letter, A, C, C. Now here we don't begin with the same letter, so what do? We apply the properties so that we try to begin by the same letter. Now, try to do it alone. If I want to flip the two letters here, I apply Chasel's rule. So BD is minus DB and this is DC. Now we begin by the same letter, but we have to eliminate this minus. And we saw in the properties that to eliminate the minus, we add a pi. So this becomes pi plus DB DC. And by now we go back to the figure. So don't come and find the measure from the figure automatically. Try to apply the properties first and then go back to the figure. Now what is the measure of angle DBDC? This is DBDC. It's a 90-degree angle, and from DB to DC we are rotating anti-clockwise, so this becomes pi plus pi over 2 plus 2k pi, which is the 3 pi over 2 plus 2k pi. Now BCAB, also here we don't begin with the same letter, so we try to manage it. Try to do it alone. Okay, BCAB is the same as BC and then minus BA. We remove the minus by adding pi. What is the measure of BC? BA, this is BC and this is BA. Remember, this is a 90-degree angle and this is a 45-degree angle, so their sum is 135. And if we rotate from BC to BA, we are rotating anti-clockwise. So this is pi plus 3 pi over 4, which is 7 pi over 4. Now CDAD, again, we don't begin with the same letter. Try to manage it. Okay, now if we flip the first vector, we get minus DC, and the second vector, we get minus DA. And here, to eliminate the first minus, we add a pi, and to eliminate the second minus, we add another pi. So as if we are adding 2 pi, which is nothing, because it's one complete rotation. So this would be the same as DC DA, and we go back to the figure, DC DA, that's it. This is a 135-degree angle, and for the orientation, if we rotate from DC to DA, we rotate clockwise, so this is minus 3 pi over 4. Now BAID. Now here pay attention, we don't begin with the same letter, and we cannot begin with the same letter if we just leave these letters, so try to manage. Well, in such a case, we try to replace one of the vectors by another vector which is equal to it or equal to k times that vector where k is strictly positive. So we either replace vector BA by a vector that is related to ID or vector ID by another vector which is related to BA. Remember, try to take equal vectors. So vector BA in this case could be replaced by vector CD, and CD is related to ID, or vector ID, this is ID, could be replaced by vector BI. So in this case, what I did is that I replaced vector ID by vector BI, and by now we have the same letter. We go back to the figure BA, BI. This is BA, BI. It's a 90-degree angle clockwise, so it becomes negative 90. So in case you don't have common letters, try to replace the vector by another vector which is equal to it. Now vector BADC, try to do it alone. Okay, now BA, this is BA and this is DC. They are two opposite vectors, so the angle in between is pi. And vector BIID, this is BI, this is ID. They are equal vectors, so the angle in between is 2k pi. Mira, Amir, or Rami. We have ABCD is a direct square, and we need a measure of the angle ADAB. Let's see what's happening. Mira states that ADAB is negative pi over 2. ADAB is negative pi over 2. This is logical. Amir states that ADAB is pi over 2. And Rima states that ADAB is 3 pi over 2. Now we can see from here that what Amir did is not correct, because if we rotate from vector AD to vector AB, we rotate clockwisely, and the measure should be negative, so this is not correct. Now, Mira's work is correct, but is Rima's work correct or not? To tell, we have to find the 3 pi over 2 minus pi over 2, which is 2 pi, so this is also correct, because the difference between this answer and Mira's answer is 2 pi. So Mira's answer is correct and Rima's answer is... Thank you.